Really good to see you all packed in here. It's very exciting. So this is the Future Decoded conference. Do you feel that the future has been adequately decoded for you now? Is it clear? Yeah? Okay. Well, in case there is any remaining uncertainty about what might happen in the future, I am going to resolve all your remaining questions in this talk. So, I am Steve. I work for Microsoft. I work on the ASP.NET team. And I know what you're thinking, okay? I know you're all thinking, but what's going to happen, right, in another 20, 30 years when my grandchildren or great-grandchildren are asking me about this talk that I went to, in which I discovered all the secrets of the future and got set up for professional success? They're going to say, how did he know what was going to happen in the future? How could he have predicted it? And I'll tell you, okay, because it's pretty straightforward. Essentially, it comes down to a thing that happened to me quite recently, a strange and possibly fictional thing, where I was speaking with my boss and I was saying, hey, why don't we set up one of those cool new collaborative websites for our team, you know, Slack? We could have instant chat and documents and all kinds of cool stuff. And my boss just sort of sneered at me and said, what? What is Slack? And I said, oh, you know, it's this it's very cool collaborative teamwork management type thing. And my boss just slammed his hands on the table and said, don't be a fool. We're Microsoft. We've got something much better than that already. And I said, what? And he said, SharePoint, of course, you idiot. So I said, well, I don't know. It's exactly the same kind of thing. He just slammed the desk again. Go and set up a SharePoint site for the team right now. So I went and did it, and I don't really know SharePoint, but anyway, I kind of made it work, and then I showed it to him, and he said, it's too slow. And I said, well, maybe I could use a server with more than 64 megs. And again, he just threw his coffee across the room and said, you fool, we're not wasting Microsoft shareholder money like that. Just make it faster. So I thought, okay, I don't know what to do, but I'll see if I can find a way of making this SharePoint site faster. So I went to the SharePoint management console, which is this thing here. Okay, now I don't know anything about SharePoint, okay? I'm not a SharePoint admin, but I just started looking around, okay? System settings, maybe? I don't know, manage services on server? And then just this big list of services appears, and I don't even know what all this stuff is, but I just started looking through it. And then I noticed this thing down here, turbo mode. And I thought, oh yeah, this could do the trick, couldn't it? So what happens if I turn this turbo mode on? So I went to start turbo mode, and it comes up with this stuff. Okay, for faster processing, SharePoint can share resources with additional servers in parallel universes. All right, cool. That sounds pretty good, right? But then there's this warning. Watch out. If the system clock is not accurate, some data loss or temporal paradoxes may occur. Wow. You know, what's the worst that could happen? If it wasn't safe, they wouldn't have put it in, right? So I clicked on OK, and it just does all this usual SharePoint kind of stuff, you know, like quantum entanglement, blah, blah, blah. But then this came up. One or more paradoxes could not be resolved. I don't really know what's going on. I mean, that sounds quite bad, doesn't it? Is that bad? I don't know. Well, let's just hope that nothing bad happens, okay? So I clicked on the OK button, and then everything just went crazy. It's like some kind of black hole into another world, and I was just like, go back, 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 back. And I got back, and it was calm, and I felt okay. And I thought, okay, hopefully I haven't caused any really severe problems anywhere. The server seems to still be working. Let's check out the actual SharePoint site itself, make sure that's still working. Okay, and it's still here, that's good, right? But then I noticed this weird thing. Because before, it was a new SharePoint site that I just set up. But now these 3 documents have appeared. What are they? Where did they come from? And why were they created in the future? Well, somehow they've come back in time. And, okay, I admit some of them are kind of boring and predictable, like how we crushed Apple again, yeah, blah, blah, blah. And this major sporting resource thing, I couldn't think of anything useful to do with that information, so I just ignored that. But there was something very cool, intranet site architecture review. Now, this has got us talking, right? We could see what an intranet site would be like if it was made in the future. So I download this PowerPoint file, and we'll try and open it, and we'll hope that PowerPoint hasn't changed its file format in the next 5 years. Come on, PowerPoint. Yes. Okay, we're in. We can see the intranet site of the future. Okay, so how are people going to build intranet sites in the future? Well, okay, some of it we could probably have guessed. ECMAScript 2015, 2016, and so on. Yeah, newer versions of JavaScript. Not surprising they would use those. Other things we maybe could have predicted as well. Web components, that's an emerging standard. Custom rendering, what are they talking about? Simplified asynchrony, Sounds good, don't know what it is. And then all these other things, WebAssembly, shared memory parallelism, CSS-free layouts. What are these things? So I did some more research. I looked through this document and some other things, and I managed to find out more details about all of these future technologies. And that's what I'm going to show you in this talk. We're going to take a boring intranet site written with 2015 technologies and convert it into a futuristic intranet site using future technologies, okay? So let's have a look at a little bit of code. In fact, let's see this intranet site first. And I'm going to warn you, it's the single most boring website anyone has ever built, okay? It is Megacorp Sales Stats. Megacorp is a future world-dominating corporation which operates in all major market sectors, including aerospace, toys, handbags, thrash metal music, and top hats, all very big in 2020. And all it does is it just lists sales statistics. Terribly boring, okay? But it's built with 2015 technologies. Let's have a look at what that looks like, and then we can see how we can improve on it. So, having a look at a little bit of code now. We can see it's built with some HTML and with some JavaScript, not very surprisingly, in 2015. So here's my HTML file. It's got some fields there where you can click on these radio buttons, and that switches between the different categories. And then all that's remaining is this table. Now, I've used a JavaScript library called Knockout.js to build that table, but this talk is not about Knockout. So if you don't know about it, or you are very determined not to know about it, don't worry, because I will not be talking about it in any detail. The most sophisticated thing I will do with it in this talk is this for each loop that's already on the screen. So it's very easy to understand. It's an HTML table that says for each of the months that we've got data about, we'll have a table row, and in each one we're going to have year, month, and sales information. Okay, so that's the HTML, not very sophisticated. Let's have a look at the JavaScript behind that. Now, this is ECMAScript 2015 code, also known as ES6. I imagine a good proportion of you are familiar with this sort of syntax by now, but if you're not, I shall just point out that this is JavaScript. It's not some kind of other language that compiles to JavaScript, it just is current day JavaScript, 2015 style. So we can do things like import statements to pull in libraries without having loads of script tags. We can have proper classes. Our classes can have constructors. We can use nice syntax like this arrow function here. That's just a shorthand way of doing an inline bound function. We can have methods on our classes. We can use string interpolation. See the string here with the backticks around it and the token in the middle? That's just an ES 2015 string interpolation string. Then I've got a fetch call here. That's just a modern way of doing AJAX requests, standard to the browser. And then I'm chaining a couple of promises on there. And that's basically the whole of the application as it stands today. So it's very boring. But let's see if we can make it a bit more interesting by bringing in some futuristic technologies. Okay, so let's see what people are going to do. They are going to use web components, all right? Web components are a way of creating custom elements and giving meaning to them. So you can define how they behave and how they look in the browser. And you can make them fully encapsulated so they can be shared between projects and reused and build your sophisticated application out of lots of components inside other components and so on. So let's have a go at doing this, shall we? Let's go back into the code here. In fact, I'll go into the HTML. And we'll say, okay, so this table element here, it's not very semantically clear that it's a table of sales information. Wouldn't it be nicer if I could have an element like this, sales chart, okay? That would be a handy element if I wanted to display a sales chart. But of course, no such element exists. The browser does not know that that means anything. So if I save that and reload, you'll see nothing at all changes. The browser just sees that as an empty placeholder element. But with web components, we can give a meaning to that element, and we can do that in JavaScript. So let's go back into the JavaScript code here, and I'm going to move that up a bit, and then I'm going to paste in a bit of code that's going to define a meaning for the sales chart element. And here's the code. I'm saying, okay, browser, I want to register an element called sales chart, and the behavior for it comes from this class called sales chart, and that extends or inherits from a regular HTML element. And inside this class, I can define callbacks for a bunch of different things that might happen. I can have a callback from when it's created, when its attributes change, when it gets removed from the document. And in fact, that's what I've done here. So I've said when this element gets created, let's stick some text into it in a very simple way. So now in the browser, if I reload, we should see hello there appears on the screen. Very good, because when the element is added to the DOM, it gets some text assigned to it. Now, you could implement a whole bunch of other callbacks to deal with all the things that might happen with that element and use regular DOM APIs to populate it and catch its events and do whatever sophisticated thing you want and build your sophisticated component like that. That's great. But before we get to that, let me just anticipate a little problem that might occur, and that is to do with encapsulation. Let me trigger a problem deliberately by putting in some badly written code. So let's say that I want my text, I've still got the hello there text, but I want it to be red. So I'm going to give this a CSS class, and I'm saying for that class, we want the text to be red. Okay? So if I come back and reload, we should see the text go red, and we do. But we also see the style is leaking out and affecting all these other unrelated elements. Now, why is that? Well, it's because my code is rubbish. Okay? So I'm matching all of the table cells as well as the primary element itself. Now, that's obviously a deliberately badly written bit of code, but the general principle is, what if there were lots of different components that all used the class name primary or selected or something like that? That's quite a plausible thing that could happen. How could you confidently reuse your components across projects if you had to somehow make sure that they didn't clash on basic things like CSS class names? That would be a real pain, wouldn't it? So this is where we introduce the idea of shadow DOM. Shadow DOM is part of the web component specification, and it allows you to say that a certain element acts as an encapsulation boundary from the rest of the document, so that styles won't leak into it, nor will styles leak out, and other aspects of encapsulation too. So let's say I want to encapsulate everything inside this sales chart element. So I'm going to say I want to define here a new shadow root. Okay, so on this element, I'm creating a new encapsulation boundary or shadow root, and then instead of setting inner HTML on this, I'm going to set it on the shadow. Okay, so now back in the browser, when we reload, we should see that our styles do not leak out anymore. Nor would styles leak in, or JavaScript. If you use JavaScript to select all elements matching a certain class or something from outside, you will not catch the things from inside, or vice versa. So that makes it much more plausible that you can reuse these things across projects. Now, I will point out that that is not a security boundary. Okay? There are still APIs for escaping from the shadow root or for getting inside it as well. It's not for security, it's just for your convenience, so you don't accidentally get clashes among your components. Okay? Right, so we're off to a good start. We now know how to make a custom element and give it some meaning. Let's actually do something more interesting. Let's say we want to create an interesting way of visualizing the sales stats. Now, how will we do that? So, as you all know, all 15-year-olds in the world today, without exception, spend all their time playing Minecraft, right? Well understood fact. Now, in 2020, those modern-day 15-year-olds are going to be our bosses, and they are going to insist that all software must look and behave like Minecraft, okay? Even, completely inappropriately, things like sales intranets. So, we will not fight against the system, we will simply accept it, and we will get used to building Minecraft-style websites right now, okay? And we're going to do that with some web components. So, what I want to do is, firstly, I'll get rid of all this junk that I just put in before, and also this sales chart from here. And instead of that, I'm going to have a custom element called voxel world. Now, voxel world is going to be the root of my 3D world, and I'm going to be able to use DOM elements to put contents into that 3D world. In this case, I'm putting in a tree. Now, in order to implement that, I will need to write a bit of JavaScript. So let's say I want to do this as a new file to keep it nice and separated from everything else. So I'm going to make a folder called voxel world. I know you can't really read that well. And I'm going to make a file in there called voxel world.js, okay? And then I'm going to put some implementation code in there, which is more or less the same as what you saw before. So just like before, I am going to say, all right, in this document, I want to register the elements voxel world and voxel tree, and their behaviors will come from these two classes, voxel world and voxel tree. Now, to implement them, believe it or not, I do not have time to implement voxel rendering from scratch in the few minutes available in this demo, so I'm going to pull in an existing voxel rendering library from this external file here. So I've taken an open source library called voxel.js or something like that, and I've made a little wrapper around it that's convenient for this talk. So that's voxel view. All right, and what we're going to deal with in this talk is interfacing with it from web components. And I'm saying, okay, my voxel world element, when it gets created and attached to the document, we'll create a voxel view and associate it with this element. And when there's a voxel tree, we will have it look for its parent node and find the voxel view associated with that, and then it can tell the voxel view to add a tree based on the height specified on this element. And similarly, when it gets detached from the document, we'll tell the voxel view to remove it as well. So, last thing I need to do to make this actually work is import this file. So I will do that with another import statement, like that. Okay, so now if I come back and reload, hopefully our voxel world will be rendered and we'll have our voxel tree inside there. Okay, looking good. Now, the cool thing about this is that it is just the DOM. So if I want to have multiple trees, I can just have multiple trees. And indeed, I can even change them dynamically at runtime. So if I've got any JavaScript technology that modifies the DOM there, and it inserts or removes trees, then they will immediately show up in the voxel world. So let's take advantage of that as a way of visualizing this sales stats. Let's say I want to plot a 3D graph inside the voxel world. I could do that by having another element in here, and I'm going to call it graph point. And I'm going to use another one of these for each loops to create a graph point element for each of the pieces of data that we want to display. So here it is. I'm going to say, okay, use knockout again. For each of the month's data, I want to have a graph point. And we will set an attribute on that graph point called value, and its value will come from the sales for that month. And that's all there is to do it, apart from, of course, I have to implement graph point as well. So I'm going to come back into my JavaScript code and drop in a little bit of code that implements what we need for graph point. And it's basically the same as before again. So we register the element graph point, behavior in this class graph point, and again, when it's attached to the document, we will get the parent node, find the voxel view, and tell it to add a graph point. If its attribute changes, we will tell the voxel view to update that graph point, and if it's detached, we'll remove it from the view. And so by implementing those three things, anytime my DOM changes, the document, the 3D view will update as well. Which means, if I come back in here and reload, we should see this ludicrously large brick wall that represents the actual sales data. And because the DOM gets updated when I click these buttons, it will automatically change inside the 3D world. So we can establish interesting facts like thrash metal music will be going downhill in popularity a little bit in the future, and the total amount of money that we make from children's toys is not very much. In fact, it's so small that I can literally jump over it. So I would recommend that maybe we spend our money investing in handbags instead, because that's going to be massive in 5 years' time. Okay, good. So we are getting somewhere with building our futuristic intranet site in a way that's entirely plausible and is a good use of your employer's time. Okay? So how else are things going to get better in the future? Simplified asynchrony. Okay? So today, if you want to write asynchronous code in JavaScript, which you do all the time, you have no choice, the main way that you have of organizing your asynchrony is with promises. Promises are an abstraction over asynchronous tasks, and they work pretty well. They provide lots of flexibility for composing your asynchronous tasks. But it's very easy to get things wrong with them, because you have to build up these promise chains that you could easily get confused about. Let me show you. So here's some code that uses asynchrony. So we're fetching some data from this URL whenever we need some sales data. And that comes back asynchronously. It's a promise. So when we get the result, we'll ask the browser to parse the JSON. And that itself is also asynchronous. So we'll chain another promise handler on it that gets the final JSON and pulls the months out of it and sticks it into the months data thing, which then makes knockout update the DOM, which makes the voxel world update, and everyone's happy. Okay, good. But you could easily get confused with this sort of promise chaining thing and do stuff in a way that is broken. For example, another way that you might have written that promise chain would be like this. And I would forgive you for not really even being able to tell the difference, because it's not exactly obvious. So here, I'm saying do a fetch, then we'll chain on a promise handler that gets the response, and inside there, we'll start another promise chain that parses the JSON, gets the data out, and sticks it in this .months data. Okay? Now that still works. It's basically equivalent. So if I reload here, we'll see it still works, and I can move around, and everything's great. But what about error handling? Now, I've deliberately created a situation where an error is going to occur, okay? Because you see how we've got top hats? Well, I'm lying to you. We don't have top hats. They are not going to be big in 2020. So they are, in fact, completely lost to history. And when I click on it, you'll see that the server is returning 404 not found from there. So we've got an error, and we're going to have a way of dealing with errors. Now, this is asynchronous code, so I can't just stick a big try-catch around it because the method exits immediately, even before the server has returned its data. So a try-catch is never going to land in the catch block. The correct way of doing it with promises is something like this. Catch, error, and then, let's say, alert, bad. Okay, some quality error handling code there. Now, if you do promises, you need to know where to put your catch blocks. It would be wrong to put catch on the inside of there because if an error occurs on the outer promise chain, then the inner one will never run, and so the catch handler would not fire. So that's one possible mistake you might make. Let's just check that this does work, of course. So if I hit top hats, yeah, okay, bad, good. All right. But you need to remember where to put the catch block. And a thing that could go wrong, if you're not very familiar with that, is what happens if you didn't have that return statement just there. It would be a very forgivable mistake for a developer not to have written return, given that everything appears to work just the same without it. You maybe didn't realize that you needed to have a return. Well, you don't in the success case. It's only in the failure case where the absence of a return means that the promise chain is incomplete and the error handling won't work. So that's the sort of mistake that people are led into making with promises all the time, and I constantly see this in my work. Promises are a rather tricky abstraction. Wouldn't it be really nice if you could just write synchronous style code? For example, if you could write your code like this. That would be way better, right? I just want to fetch the data from this URL and then just read the JSON out of it and then just stick all that in months data. But of course, you can't, because all these APIs are asynchronous. So if you do that, you're just going to get errors. Response.json is not a function. You're doing it wrong. Okay? So wouldn't it be nice if we had some way of making this actually work? Well, if you do any C# today, you'll be familiar with a way that you can write your code like this, called the async and await APIs. Now, this allows you to write asynchronous code that looks like synchronous and without getting bogged down with asynchrony all the time. And the good news is that this is coming to JavaScript too. This is not JavaScript number 2, but JavaScript also. It's on the pipeline for ECMAScript 2016. And when this lands, we will be able to write async on our function definitions. And whenever a function is marked as async, you will be able to say, if there's a promise, I can simply await it, like that. Okay? And what's even better is, if you want to do try-catch around that, you can. And it will work. Okay, let's see. I just had regular synchronous looking code with try-catch around it, and let's see, in successful cases it all works, and in an error case we correctly land inside the catch block even though it's all asynchronous. So that is going to make our lives a lot better, and there'll be much fewer opportunities to get lost in promise chains. Okay, good. Right then, let's move on a little bit. What else are people going to do in the future? Native code on the web. Well, why would you want to do that? What are they talking about anyway? Apparently, in the future, they can bring C libraries into their application. They can even write their application code in a traditionally native compiled language like Rust, Go, Swift, Grog, whatever that is. I don't think that's been invented yet. And that's interesting, right? And this all comes down to WebAssembly. Now, WebAssembly is effectively a newer name for ASM.js. It's a set of standards that allow browser makers to use a particular dialect of JavaScript that's a bit like assembly code. It's highly optimizable, and you can use it as a compilation target from other languages. I know that sounds all a little abstract, so let's actually see it, shall we? Let's do some. So what's the scenario then? The scenario is that our 20-year-old boss spends a lot of time on planes. And even in the future, they still don't have reliable Wi-Fi on planes. So he or she is very annoyed about this and really wants this magnificent intranet site to work offline. How are we going to make it work offline? Well, we're going to need to have some way of doing things like these queries, these advanced where clause queries inside the browser. How are we going to do that if we don't have a proper database in the browser that we can talk to? Well, a while ago, there used to be a standard called WebSQL, which was a client-side database, but that standard got deprecated and lost. And then current browsers support something called IndexedDB, which is another client-side database, but it's quite limited. What I want is a proper relational database that I can have in the browser. And to get one, I'm going to bring in some native code. I'm going to use a proper relational database that's written in C that all of you in the room have already used today, probably. It's called SQLite, and it powers basically every mobile application that you use. It is not designed to be compiled to JavaScript, but let's see if we can do it, shall we? So, how many of you have written any JavaScript in your lives? Any C in your lives so far? C programmers. Oh, about a quarter of you. That's not bad. All right. So, those of you who have never written any C in your lives, can you guess what this C program does? Yeah? All right. So, if we want to compile that to native code, we can use a native C compiler, GCC, to compile this to a native binary called hello world. Okay? And I can execute this native binary now, and it says hello world. Very good. All right, but what if I wanted to compile it to JavaScript? This is where mscripton comes in. Mscripton is a compiler that takes LLVM intermediate bytecode, which is the output from a bunch of different compilers, including the LL whatever compiler, Clang or something like that, and other compilers. For example, the Swift compiler or Rust, I think, can produce LLVM bytecode, and then it can turn it into JavaScript. Let's have a go. All I have to do is say, instead of GCC, I'm going to use MCC, and I'm going to produce an output called helloworld.js. And that is going to be regular, real JavaScript that I can execute inside any normal JavaScript environment, such as Node.js. So let's run helloworld.js, and it says hello world. Okay, good. So we've compiled some C to produce JavaScript that runs inside Node. Could we do this with a bigger, more realistic piece of code? For example, the SQLite database source code. Obviously we can, otherwise I wouldn't be talking about this, but let me show you. So I've got SQLite here, and I'm going to compile it to native binary. So GCC SQLite.c, and I also want to compile it with this little shell file here, and that produces a command line shell that I can execute. So let's invoke shell now, and this is SQLite in the command line, and I can do things like evaluate help text, okay? And I can also evaluate SQL queries, such as this rather advanced one there, and we can do other things like defining tables, indexes, and boring stuff like that, okay? Is this going to work in JavaScript? Let's try it, shall we? So just like before, I'm going to switch over to MCC and produce an output shell.js. And we will see whether we can successfully execute this as a JavaScript library inside Node.js. It takes a little longer to compile than the native code because it's doing a lot more. And it's warning me that it's such a big file that you really should optimize it, otherwise it's not going to be performing at its best. Let's not worry about that just now. Let's invoke shell.js inside Node. And when that runs, just like before, we've got SQLite running. And just like before, I can do things like evaluate its help text or evaluate even more advanced SQL queries, which all work successfully. Great. Is it going to work inside a browser, though? Let's find out. So, back in my browser, I want to not be making requests to these URLs whenever I want some data. So I'm going to get rid of that, and I'm going to get rid of all of this junk that I put in before, and I'm going to replace it with calls to a local SQL database running inside the browser. So firstly, I'm going to have to import this SQLite file that we've compiled. So let's bring in import SQL from this file. Now that is not actually just the output directly from mscripton, because the output from mscripton on its own is really low level. It's just a load of functions that you can invoke directly. It's not object-oriented, it's not stateful, it's just these functions that you can call. So most of the time, if you want to use it with regular JavaScript code, you will build your own little wrapper library around it, which gives you a nice object-oriented kind of API. And that's what I've done here. So this is, I've actually stolen someone else's hard work and slightly modified it to make a nice API for SQLite. Okay? But the underlying implementation is the thing that we just compiled. So now I can create an instance of a client-side database. Okay? And that's what I'm going to do here. So I'm instantiating a client-side DB, and I'm telling it to asynchronously fetch from the network this SQLite database file. And this is the actual same binary data that the native SQLite client would work with. It's not some JSON file or other special JavaScript thing. It's just the same regular SQLite binary data. Now, obviously, if you are going to ship databases down to the client, there are some security considerations that you should bear in mind. I am going to assume that every end user of your application has their own private SQLite database file, which is just there for the purpose of being able to work offline. You obviously can't share databases across users like that, because if it's running in the client, anyone can see all the data and modify it in any way they want. So let's assume that this is user-specific. Okay, now we've got our client-side database. I want to query it. So just like before, I can use the await method to wait for that query to complete. So let's do that, the tricky thing is remembering which of the many snippets you want to use, and it's this one. Okay, so I want to wait for the client-side database to run some SQL. Now, has anyone written any SQL in the last few years? You remember that? Yeah? You remember it? Okay, it was pretty cool. What we used to do back in the day is we would have this select, and then we would say what we want to select and where we're selecting it from. And in this case, all I'm doing is just selecting from a sort of dummy table that I've created called ascending sequence, which is just an ascending sequence of numbers. We'll await for that, and we'll stick the results into the same place as before. So let's see if this actually works. Come back and reload, and hopefully we will see a sequence that literally ascends into the heavens there, and that is coming back from this client-side database that's running inside the browser. Okay? But I don't want to just display this ascending sequence. I want to display the real data that's coming back from my sales figures. So let's replace this again with the actual data. And I'm going to use another ES 2015 syntax feature here. You see here how I'm declaring two variables simultaneously. This is called destructuring. I'm declaring a variable called query and another one called params. And what I'm doing is saying, if you are trying to query across all sectors, then I want to use this SQL query. It has no where clause in it, and it requires no parameters. But if you are querying for something else, I want this SQL query here, which does have a where clause in it and a nice sort of group by. And also I need to specify a parameter for that, which will be whichever sector it is you're trying to query for. And that defines these two variables. And I know someone's going to come up to me afterwards and say, you should not use var, you should use let, because that's the modern keyword. But notice, I don't get syntax highlighting. So I'm going to use var, and we're all going to be happy, okay? We're not going to complain or tweet about that. So we will wait for the client-side database to run this query with those params, and then we'll stick it into the same observable array, and everything else should hopefully update. So reload, and now it's going to do the actual query, and we're going to see our real sales data, and we can do the same stuff as before, where we press back by mistake. Try that again, and there we go. We can see that it's all working the same as before. I will ignore the JavaScript error. I must have typed something wrong. Okay, so that is all working, and that is pretty cool. So we have got a native relational database, which we've compiled to JavaScript. We're running that in the browser, and we're using that to use, with the await keyword, to asynchronously, but it looks like synchronously, wait for a query to return, and then we'll use that to populate the DOM with some custom elements, and we'll use that to render in this voxel form the sales database. And that is the delightful future of web development that awaits us all. Okay, so good. Let's move on a little bit. Let's think a bit about performance, okay? So if you compile your native code into JavaScript, today the performance you're going to get is, if you run it without optimization, is in, for example, something like Node.js, it's going to be about 1/8 to 1/10 the speed of the native code. If you run it in a browser that does have optimizations, which is basically all of them these days, the thing that used to be called Asm.js, you'll find the speed goes up to about 50% of native speed, which is pretty fantastic that we can take this native code and run it to within a factor of 2 of the same speed. But native code still has a few advantages that JavaScript does not yet have. And one of the main things is it comes down to parallelism. If you're writing native code, there's a bunch of tricks that you can use. For example, single instruction, multiple data. That is a way of writing special CPU instructions that operate on a whole group of data items in a single instruction. And so that can be 4, 8, 16 times faster than doing the operations one after another. Good news is this is coming to JavaScript too. There's the proposal simd.js, which provides some nice APIs around that facility of the modern CPU. So you'll be able to get to use that. Also, shared array buffer. Shared array buffer allows us to escape from one of the performance limitations that JavaScript developers face today. Let me explain what that is. Okay, so today, if you want to write properly parallel multi-threaded code, you have to do so using web workers. It's the only API available to you. Web workers lets you spin up actual real threads that run simultaneously, but they have a rather severe limitation that each one of those threads is only allowed to access its own private isolated block of memory. And this is important because that allows JavaScript to retain the same order of execution guarantees that you get and you have had since JavaScript was well invented in 1922 or whatever it was. And in order to maintain that, they cannot let you have multiple threads that mess with the same block of memory at the same time. And that's okay for certain types of parallelism. For example, if you want to factor a large number, that's cool because you can send the large number into your worker thread, and sometime later it'll send you back a message saying, I just cracked the encryption, here's the keys, and that's great. But it's not good for other types of parallelism. For example, if you wanted to implement a game engine, it's no good for that because what you would have to do is send, for example, the complete state of the entire game world into the web worker on every single frame, which would be a massive amount of data, and then on that same frame, it would have to send you back the complete updated state of the game world. And that is not going to work because the sheer amount of data that you're serializing to send over these message channels here would be so expensive that it would hugely outweigh the benefits of parallelization in the first place. So if parallelism is going to benefit you, you need to have shared state. That's how most kinds of high-performance game engines and many other high-performance multi-threaded pieces of code work. And that's what shared array buffer lets you do. It's a special kind of array that's never been possible before in JavaScript, and it's special because it does not have memory safety guarantees, which other arrays do. By creating one, you're saying, okay, for this array, I'm okay with the fact that many different threads can all just mess with it at the same time, and I'm not going to have any guarantees about who does what and in what order. And as long as you can manage that, then you can get potentially significant speed-ups in your code. So let me give you a very quick example of that. I could not think of a sufficient contrivance to bring that into Megacorp sales stats, so I'll show you a separate example. Okay? This is something that will hopefully be a little bit familiar to some of you in part. So this thing that's running here, this weird pattern that's happening, this is something called Game of Life. I bet a lot of you have heard of this before. It's also called a cellular automator. It's basically a very, very simple set of rules, like 3 rules, which seem like they're very simple, but when they're all combined, they produce very complex behaviors. And this one produces something that looks a bit like bacterial organisms that sort of move around and eat food and reproduce and die and so on. So it's all very complex, but it just comes from a small number of instructions. So that's fine, but it's quite computationally intensive because on every single iteration here, the new state of the world depends on every single thing in the previous state of the world. So we can't really parallelize this well with regular web workers. We would again have to send the complete state of the world into our web worker and then get it back. You couldn't really split it up over multiple workers. What we want is shared state parallelism, and that's what shared array buffer lets us do. Now, I won't have time to show you code in any detail here, but just to prove in a hand-wavy kind of way that it does something, here's the implementation here, and you can see that it's got num workers equals 1. If I change that to 4, then what was previously taking about 60 milliseconds per iteration gets a lot faster. It's down to about 17, 18 milliseconds. So we're getting almost a factor of 4 speed up from that. And the reason that is happening is that I'm using a shared, in this case, a shared unsigned int 32 array. That's one of the many types of shared array buffer that exist. And I can allow my different threads to all just play with that block of memory simultaneously. And as long as they don't trample on each other, we're going to get some serious performance improvements. So I'm not going to show you any more of that. And hopefully you won't even have to write much of this code yourself. But it's just good to know that if this low-level primitive exists, then when you write something like code that compiles to Awesome.js, it should be able to take advantage of this and just produce some free speed-ups for you. Great. Okay, last thing that we're going to have time to look at, CSS free layouts. Now, this is the most tenuous thing in this whole talk because this is not on any standards track that I know of. Now, CSS, is it good? Is it bad? I know you've all probably got different opinions about this. I sometimes think it's quite cool, and sometimes I am still shocked by how difficult it is to do seemingly basic things. And the classic example is, of course, centering things, which is just, you know, you need a PhD to be able to correctly center one thing inside another, and there's anything you do is going to go wrong with that. It's crazy. Okay, so what if in the future, instead of using CSS, there was a completely different way of specifying layouts? What would that even look like? How else could you possibly describe a layout other than CSS? Hard to imagine, right? Well, one possibility might be something like this, a constraints system. If any of you do any iOS programming, you may know that one of the ways that Apple allows iOS applications to define the layout of their UIs is as a set of constraints that the runtime solves in order to decide where all the buttons and stuff go. Okay, so to give you a simple example, let's say I want to lay out these green boxes in the way that you can see there. I might do that by saying, okay, I want the left-hand edge of all the B boxes to be equal, lined up with each other. And I also want that position to be 20 pixels further right than the right-hand edge of box A. So that defines a little bit of how things are laid out horizontally. But it doesn't say anything about how they're laid out vertically. So maybe I also say, all right, I want the center of box 2 vertically to line up with the center of box A. And I want the top of B1 to line up with the top of A. And I want the bottom of B3 to line up with the bottom of A as well. And that defines more things that the constraint solver can use to decide where stuff goes. But we haven't yet said what these sizes of these B boxes are, or what the gap between them should be. So maybe we actually don't even say. Maybe we just say, I want all the gaps to be equal, but I don't actually care what the value is. And the constraint solver will pick a suitable value that satisfies all the other constraints. Okay, so let's see if we can do a little bit of that. So I'm going to go into my browser, and I'm going to very quickly show you a simple bit of layout. Okay, I'm not going to have time to get into this very much, but I'm going to show you putting a constraint in. So I am going to show you the code for this, layout.html. Okay, and you can see inside there I've got this left panel and I've got this right panel. Okay, they display this text, left panel, right panel, and I've got some constraints. And notice that instead of text CSS, I've got text GSS, Grid Style Sheets. Grid Style Sheets is an open source library for doing this constraint-based system. And it's the worst possible name they could come up with because it's got nothing to do with grids whatsoever. It's just a constraints-based layout system. And it's not supported by the browser, of course, so that's why we've got this JavaScript library, GSS, that actually implements it. And I can do something like this. If I want to define the width of this left panel, I might say, okay, we'll say the width of it is going to be 1/4 the width of the screen. And also, even more importantly than that, I want the width to be always at least 150, but never more than 250. Okay? So, that being done, if I come back and reload, then if I make the window resizable, you'll see that as I resize the window, it does continuously stay 1/4 of the width of the screen, but it will not override the more important constraint that it can't be less than 150. So that is how we can define constraints. I'll show you one last constraint. So let's say I want this right-hand panel to fill up the remaining horizontal width of the screen. I can use another syntax called Visual Format Language, VFL. And I think this is Apple's specification. So it allows you to use this sort of ASCII art style way of describing your layout. I'm saying line some stuff up horizontally. I've got the left-hand edge of the screen, which needs to touch the left panel. Then we'll have a 20-pixel gap, and then we'll have the right panel, which touches the right-hand edge of the screen. So even though I'm not specifying the width of the right panel explicitly, in order to satisfy the other constraints, the browser will correctly make it the right width. So it goes from 20 pixels right of the left-hand left panel all the way to the right-hand edge of the screen, even as the left-hand panel changes. And we can use this to build up arbitrarily sophisticated layouts. I don't have time to show you, but we've got loads of things that can be done inside GSS. For example, you can do things like aspect ratio constraints, which there's no way of modeling with regular CSS. If you want to horizontally and vertically center something, you can do something as simple as like That is how to center one element inside its parent. We say the center of this element is the same as the center of the parent, that kind of thing. If you want an element to fill up its parent, you can do something like this. The size can be as big as it likes as long as it fills the parent, and so on. So that's grid style sheets, and that's all I have time to show you there. So that's a constraint-based layout system. If you're interested in which of these you could actually do today, let's quickly summarize. Well, ES 2015 syntax, yes, you can and should do that by means of a transpiler. That is absolutely ready for you to use today, and you should do. Web components are limited to certain browsers. Fairly recent browsers can be polyfilled, and it's a standard that's coming to all browsers fairly soon. The async await, you can basically do that as well through transpilation today. The WebAssembly thing, even though browsers support optimizing it, you still have got to ship quite a lot of JavaScript code to the browser to make that work. So that's only really applicable in certain scenarios like intranet sites or maybe games, not so much regular public websites. For the parallelism stuff, shared array buffer and so on, no, there's no way you can use that today, I'm afraid, because it's a runtime feature. It cannot be polyfilled, so you're going to have to wait on that, but it's nice to know that it's coming. And finally, the constraints-based layout system. Well, can you use that or not? Well, you sort of can, okay, because there's the GSS JavaScript library, which you can use if you want to, but you'd have to be pretty brave, okay, because very few people in the world are actually doing this today. So you'll be one of the early adopters and discovering all the problems. But if you like it and you get excited about it and you blog about it and you speak about it and so on, maybe that sort of thing could end up being a standard. So that is all we have time for today. I hope you have found that an interesting insight into the way things are going in the future. I've been told to remind you that the Brian Cox thing is starting downstairs fairly shortly, so you should head down to that as soon as you can and get yourself a good seat. Thank you very much.